Hi everyone. Today we're going to continue our investigations on life sciences. If you remember last week, we planted albino corn and we went over the results, but I actually kept them a little bit longer and we can study them a little bit more and observe what happened when we left them for 2 weeks. Let's take a closer look at just 3 of the different cups that I have the albino corn planted. And in all 3 cups, what do we notice? Are they growing exactly the same? They're not, right? The green ones are much taller than the white ones. Last week when we looked at them at 7 days, it looked like they were growing at about the same pace, but all of a sudden, the white ones, the albino ones, slow down, but the green ones continue to grow and get so much taller. Let's bring it up close. So this albino corn not only affected the color, but it also affected the height. And this was something that we had to wait for to see. We couldn't see the results immediately. There's one more thing I wanted to discuss before we put these plants away. If you remember, we planted 2 seeds in each cup. And then I gave each of these cups exactly the same treatment, right? I gave them all the same amount of water. They all got the same amount of sun. They all had the same amount of soil. They were all planted on the same day, so the weather, the climate, everything was exactly the same. However, what was different? Their genetics, right? We didn't know what we were planting. They all were corn seeds from the same parent, but genetically, some had the genes to express white petals and some were green. And the ones that were green look like they are even healthier. They don't look like, the white ones are not doing as well as the green ones. Now my question for you today is, well, what if they didn't all get the same treatment? What if we planted very similar corn seeds that didn't have any genetic mutation, but we gave them less of something? What are some things that we could change in this experiment? What are some of the variables that we could modify? Could we change the amount of water we give our plant? Sure. Could we change the amount of soil that we give our plant? Sure. Could we change the amount of sunlight? That's something else we could do, right? Think about it. Think about what other things you could change in this lab. For this lab, you're going to need 6 cups or containers, the bag of soil from your Ziploc that was in your enrichment bag. You will need water, you will need a pipette, and you will need a packet of your yellow corn seeds and a ruler. You're going to need 6 cups or 6 of your own containers. Any container will do. You're going to need water and the pipette that we used from last week. You guys should have kept that. And you're going to go back into your enrichment bag. And from your enrichment bag, you're going to take out a bag of soil. And this time we are taking out the yellow corn. The albino corn should be all used up. And now we have the yellow corn. We're going to do a planting experiment again with our corn seeds. However, this time we're going to change things up a little bit. The seeds, remember I told you, these are all genetically very similar. They do not have any mutations in their DNA. There's no more albino corn. These are all just regular corn. What we're going to do though is we're going to change the way we treat them. We're not going to all treat them exactly the same way. We're going to treat half one way and half another. So I'm going to set up my 3 cups. And what you're going to do is you're going to fill up your cups with soil, and they will all get the same amount of soil. Now I have filled up all of my cups with the same amount of soil, almost the same amount. I measured just by eyeballing it. If you have any soil left over, that's fine. You're not gonna need it anymore for our labs, but you can save it and do another lab with materials you have at home. You can put that away. And now you're going to take your manila envelope with the yellow corn seeds. You're going to open them up. And you should have at least 6 corn seeds. If you have more, that's great. And you can plant more, or you can plant multiple in the same one. But I'm going to take 1 corn seed and I'm going to place them inside of my cups. And you can look and see these corn seeds. Do they look any different than last week's corn seeds? Very similar. I'm going to take my pipette and just gently push it right under the soil. Now we've done a similar experiment before. What would happen if I gave one group water and another group no water? Well, we know what would happen, right? The ones with no water wouldn't grow at all. All living organisms need water to grow. These seeds are alive, they're in their dormant stage, and they just need to be woken up, and the water will do that. So that's not the experiment we're going to do today. What we're going to do is we're going to change the amount of water we give our seeds. And for this, you might need some labels or a piece of tape, or you can write directly onto the cups. I'm going to label 3 of the cups with 9 milliliters, and I'm going to label 3 of the cups with 18 milliliters. And that refers to the amount of water we're going to give the corn seeds. So I'm going to place 9 on these 3. And 18 on these 3. And I have my pipette, I have my water. Now remember, I told you this is the pipette that we use, this is the bulb. You do not need to get the entire bulb filled to have 3 milliliters. If you look, there's a line right on the pipette that says 3 milliliters. Now, if I want to add 9 milliliters to this cup, how many times do I have to fill this pipette? 3 times, right? 3 times 3 is 9. Going to go and add water. Oh, didn't get it quite to 3. There we go. That's 1, 2, and 3. And I'm going to do this for these 3 cups. One, 2, 3. 1, 2, and 3. Now these cups are going to get twice as much water. They're going to get 18 milliliters. So how many times do I fill these up? 6. 1, 2, 3, 4, 6. Now I have 2 sets of cups. The first set, I have given them each 9 milliliters, and the second set has each gotten 18 milliliters. Now you're going to keep these either inside or outside in a safe place, somewhere where it gets a little bit of sunlight, and you're going to have to take care of them daily. You're going to have to come and watch them. Now I have already completed my experiment, but when I did this, it was a very, very hot and sunny day. As you can see, today is not so hot and not so sunny. So it also depends on the week. Listen to what you're going to do. If you water the plants, you have to water both. But if you come and you see, oh, there's so much water, it doesn't need water today, then neither one gets water. But if you do water it, the first set will get 9 milliliters and the second set will get 18 milliliters. What I recommend is watering them every other day. I think that should be safe, especially if you keep it indoors. The water will not evaporate as fast. So remember, every other day, 9 milliliters, every other day, 18 milliliters. On the same day, you're going to water them, but you're going to skip a day each time. And you're going to let these grow for about 7 to 10 days, and then see what happens. Now here is a great place to pause and fill out your hypothesis. What do you think will happen? Remember, a hypothesis is a guess or a prediction. What do you predict that these cups will look like? Do you think that these cups will look the same? Do you think that the plants will grow at all? Do you think that the plants will grow at the same rate? Or do you think one will grow better? If you think one will grow better, which one do you think will grow better? Fill out your hypothesis, and then we're going to go over our results. Now here is a picture of my plants that were given 9 milliliters of water after 4 days of planting. There is one with a small sprout, but you do not see a lot of growth overall. And in the next picture, here's another set of corn seeds that were planted. Again, you see something small starting to sprout, but not major growth after 4 days. Now in the following 2 pictures, these are plants that were given 18 milliliters of water, and you can definitely see growth is starting a little bit faster here. The sprouts are more visible coming up from the soil. And in the next picture, these are also cups that were given 18 milliliters of water after 4 days. And these cups also show the sprouts a little bit more visible than the plants that were given just 9 milliliters of water. Now, here are my results. Like last week, I planted more than I normally would for one student or one experiment. I planted more because if we were back in the classroom, we would be able to compare our results to an entire classroom full of results. So I have 7 cups that I have planted corn, and I've actually planted 2 corn seeds in each of my cups. And these cups got 9 milliliters of water. And on this side, I have another 7 where I planted 2 corn seeds in each, but these plants got 18 milliliters of water. Can you look? Can you see a difference? Let's do a close-up. Now that we have a close-up, I have one row lined up with 18 milliliters of water and the other row with 9 milliliters. Now the first thing to notice is that with the 9 milliliters, looks like they all grew. Do we have any that didn't grow? We have one that's a little bit slow to grow and another one that didn't grow at all. But it looks like for the most part, everything did grow. But let's compare them side by side. Does one look like it grew faster? Well, the one with 18 milliliters definitely looks like it's not only taller, but it's faster in its growth. It has some leaves already. Let's compare the next two. Well, this one looks like it's taller. That one, not so much. What about these? Definitely looks like this one again is taller. Here, this one looks a little bit taller, but the second one is really slow to start. These two, this one is definitely taller than the rest. And you can go ahead and check your results. And the other thing you can do is actually use the ruler to measure the height of the plant with 18 milliliters versus the plant with the 9 milliliters of water. Let's compare the tall one here. Let's see how tall this is. A little under 4 millimeters. And let's compare it to this one. Well, this one is about 5.5 millimeters. Definitely taller. Go ahead and observe, record your results, measure the height of the corn, and fill it in the chart. And let's discuss what is happening. Did we notice a difference when we added 9 milliliters versus 18 milliliters? I think so. These have only been sitting for 7 days, but you can keep them for longer and watch and see what happens, and keep watering them every other day, the same amount, 9 milliliters and 18 milliliters, and see what happens over time. We see some of the plants here that one grew well when the other one didn't. It's possible that this one used up all the water and this one didn't have enough water. You should have one corn planted per cup, so your results may be a little bit more accurate than mine. And the other question that I want to ask is, we gave this one more water and it did better. But what if we gave it a lot more water? What if I gave this one 30 milliliters of water? Do you think that would be a good thing? Do you think too much water would help it? Remember, all living organisms need water to grow. If this had too much water, well, you could get other organisms to grow that we don't want. You could get mold and bacteria and other organisms that may come and say, oh, well, there's water here, I'm gonna start to grow. So that may not be great for the plants. So the plants need, within a range, a certain amount of water, but this one got the lower end and this one got the higher end. Now you can think about what happens in your own home. If the adult in your home asks you to drink your milk or eat your vegetables, do you think that makes a difference in our growth? Well, we also have genes and we have genetics, and our genetics determine what we're going to look like and our height. But do you think better nutrition will help us? I think so. Now, it's not a result that we'll see overnight or even in a week or a month, but over time, this is a result that may show itself in a year or two or even longer.